Hello everyone. In the series of learning database management system, our today's topic is third normal form. So as I told in the earlier videos also, normalization is all about rules. And we are doing normalization to remove the redundancy and anomalies. So for first NF, there was the rule that it requires atomicity. For second NF, there was a rule that it requires partial dependency. So here are the rules for third NF. So please see the definition first. A relation is in third NF or third normal form if it is in 2NF. That is the basic requirement. So it should be in 2NF means what? There should not be a non-atomic value and there should not be any case of partial dependency. Then it will be in 2NF. Another rule is if there is no transitive dependency exists, we will call a relation as in third NF. Now understand what is a transitive dependency, and your 3NF doesn't allow this transitive dependency. So understand transitive dependency. A functional dependency, if we have a functional dependency in a relation, X determines Y. So there is a dependency of X on Y. In a relation schema R is a transitive dependency if there exists a set of attribute Z in relation R that is neither a candidate key nor a subset of a key, and both X determines Z and Z determines Y holds. So what basically this means? This means that if there is a functional dependency, which means what? X determines Z. So if we have a functional dependency, X determines Z. That, and one more functional dependency we are having, Z determines Y. Now I am considering, because we want to check that this relation is not in 3NF. So when we are saying there is a transitive dependency, if this X is candidate key, we are considering this as candidate key. Okay, this is a candidate key. That means what? This X is a prime attribute. Now key is determining a non-prime attribute. No problem, this is a non-prime attribute. But now what is happening? Here a non-prime, because Z is a non-prime attribute, is determining another attribute which is not the part of the key. See, your definition is saying the same thing. If there exists an attribute Z that is neither a candidate key nor a subset of any key of R, if this Z is not a candidate key or nor a subset of any key of R, that means what? This is a non-prime attribute. And then also there is a dependency from non-prime attribute to non-prime attribute. Correct? So when we have a dependency that is from non-prime attribute to non-prime attribute, we will call it as transitive dependency. So what is a transitive dependency? Whenever you will find a dependency where on left hand side also non-prime and right hand side also non-prime attribute, then we will call it as transitive dependency. This was not a problem in 2NF. 2NF only deals with partial dependency. Partial dependency means, for partial dependency, this is what? This is transitive. So this one is transitive dependency. What is partial dependency? Partial dependency was this side prime, a subset of candidate key. Remember, those elements which are part of candidate key, we call them prime attributes. So this side prime attribute, and on the right hand side, if we get a non-prime attribute, then this particular we will call what? This is a case of partial dependency. So your 3NF doesn't allow transitive dependency as well as partial dependency. Fine. So point to remember for you. If left hand side X is a part of candidate key, left hand side, let us suppose there is a relation X determines Y. If there is a relation X determines Y, and left hand side, what is left hand side? This is left hand side, and this X is a part of candidate key. That means what? It is a subset of candidate key. Then it is a problem. So what it is violating? It is violating the condition of second NF. That means partial dependency. So we don't want left hand side prime and right hand side non-prime. If it is so, it is a case of partial dependency. Another thing, if left hand side X is a non-prime attribute. Now left hand side, if I will get a non-prime attribute and it is determining something, so it is a case of transitive dependency. This also I don't want. So point to remember for 3NF, these 2 points are there. If left hand side you are getting a prime attribute, it is 2NF. It is violating the condition of 2NF. If left hand side you are getting a non-prime attribute, it is violating the condition of 3NF. Okay. Now understand why we have this problem, why this transitive dependency is creating problem, and why we need 3NF to resolve this problem. Now consider a table, or let's say this is a student table. Now for this student table, I am having a student name, I am having student's major subject. So major means it can be CSC, it can be EEE, ECE. So branch you can say, so major. And we are having the department of this student. Okay, functional dependency is something like this, that S name determines major, S name determines department, and major determines department. So they are the functional dependency. Now if you can see this, I can easily tell that this relation R or this relation student, S name is determining both. S name is determining major and S name is determining department also. So if I will take closure of S name, I will get this entire relation. That means what? Candidate key is what? Candidate key is S name. And that's why prime attributes are only one attribute I am having in candidate key. So prime attribute is what? S name. And what are the non-prime attribute? Non-prime attribute are major and department. So major and department are the non-prime attribute. Now first we have to check whether this is in 2NF or not. Now there is only one element in the candidate key, so no subset of this. There is no subset. So case of partial dependency will not come, because S name is alone the candidate key. There are no other attribute, so there is no chance of subset finding any other attribute. So we are very sure that this table is in 2NF. Now I have to check whether this is in 3NF or not. What 3NF says, when a non-prime attribute determine a non-prime attribute. S name is a candidate key determining major, no problem. Candidate key determining another non-prime attribute, no problem. But major, which is a non-prime attribute, is determining department, which is again a non-prime attribute. So here is a problem. Because of this particular relation, here it is a case of transitive dependency. Okay. Now when we have transitive dependency, mainly we have to deal with the problems of anomalies. Why anomalies? Because see here what is happening. There is a relation and S name is my candidate key. This major is a non-prime attribute and department is also non-prime attribute. Now, if I want to insert a new major, let us suppose in our university, one new subject as a major, let us suppose machine learning is coming as a new major. Now, what is the problem? This major is dependent on S name. So, till the time I am not having any student who is enrolled for this major, I cannot introduce this major because there is a dependency here. We can't insert the value of major along with the S name because there is a dependency on the value of S name, and here there is a dependency on department as well. Let us suppose I want to introduce a new department. Now, if that department is not offering any subject for now, or that department is not having any student for the instance, that instant there is no student, I am not allowed to do that because there is a dependency. And this is known as what? This is known as insertion anomaly. Because of some other value, I am having problem in insertion. So this kind of problem is known as insertion anomaly, and that is occurring due to transitive dependency. Now, similarly understand like this. If I want to delete some value, fine, I want to delete a value of some student, and let us suppose that student is alone for some major. There is a subject AI and only one student is studying that subject, and that student belongs to EC department. Now, if I am deleting that student, my major is going, that's okay, but my department details are also going because there is a dependency non-prime to non-prime, which is major is determining department, and only one student was there from EC department who was studying that major. That means I lost complete details of EC department, right? So this kind of anomaly is known as what? This is a kind of updation anomaly. So these anomalies occurs when we are trying to deal with transitive dependency, and 2NF was not handling these dependency. That's why we needed 3NF, so these dependency can be handled properly. So 3NF came to demand so that it can deal with a dependency where non-prime attribute determines non-prime attribute. Okay, so what we have to do in this case? What we have to do? We have to remove this transitive dependency. Now, decomposition will work as we were doing in second NF. Similar way decomposition will work. What we can do? One table I will have for key and the attribute which is completely determined by the key. So one table we will keep for that particular attribute. So here you can see what is a candidate key. In this case, S name is the candidate key. So one table I will create. This is a student table. I will divide it into two tables. One table I will tell as student major table, and another table I will call as major department table. Now how I am doing this? See the dependencies. S name determines major. So first table I will have for candidate key. So here S name will come, and any attribute which is fully dependent on this. Yes, here major is fully dependent on this. Now, department is also dependent on S name, but what is happening? Major is saying I am having the power to alone without SNAME also I will be able to determine department. So we are creating here two tables, where because department is also depending on major, so we are not keeping the department here in this table. We are creating another table as major department, and we are making this major as a key for this department. So for this department, this major will act as a key and department will be dependent on major. So what happened for this table? SNAME is the key and major is dependent on SNAME. For another table, major will act as a key. So this dependency will solve. Now major is no longer a non-prime attribute. Major became the key. So it is allowed that a key will determine another non-prime attribute. This is allowed. So this problem of transitive dependency we resolved by decomposing the table into two. So now there is no transitive dependency. So we can say that this table is in 3NF. Okay, let's solve few more examples so the concept will be more clear. Now, one more thing, students. What happened when you solve the questions of GATE or any competitive exam? There you will get a question like, check whether the table is in, or a relation is in 3NF or not. That time if you go with the conventional way, that whether the partial dependency exists, transitive dependency exists or not, it will take a lot of time. So in the next video I will teach you some short trick also, so you can solve the question efficiently. Okay, now let's see one more example and find out whether it is in 3rd NF or not. So here, for example, I am having a relation R with attribute A, B, C, D and E. Okay, now dependency is something like this, that A determines B, B determines E and C determines D. Now first what we have to do? We have to find out the candidate key. How to find out the candidate key? Find out who is the director of the show. So let's do it. A, B, C, D and E. A determines B. A is giving directions to B. B determines E. B is giving directions to E. Then C determines D. C is giving directions to E. Who are the important elements who are not having any incoming edge? So AC is the important element. If I will find out the closure of AC, what will happen? A determines, first in the result set I have to write down the elements for whom I am calculating the closure. So AC. Now A determines B, so ABC. B determines E and C determines D, so A, B, C, D, E. I hope this is clear. That means what? AC has the power to determine the entire relation R. So can I say AC is the candidate key? So AC is the candidate key. Okay. Now, if AC is the candidate key, what are the prime attributes? Prime attributes are A and C. What are the non-prime attributes? So non-prime attributes are other than AC. So B, D and E are the non-prime attribute. Okay. Now check the dependencies. So how I should check? First I have to check A determines B. Now A determines B. A is what? A is the subset of candidate key. Subset of candidate key means what? This is creating partial functional dependency. This is creating partial functional dependency. If you can see, here I have taught you the short point to remember. If you remember, I have given you here one point. Left hand side X is a part of candidate key, then it violates 2nd NF. If you can see, AC is the candidate key. Left hand side, it is a part of candidate key, so it is creating problem of 2nd normal form, partial functional dependency. And then you see here, B determines E. B is what? Non-prime attribute. B is a non-prime attribute. E is what? Non-prime attribute. So here it is creating the problem of transitive dependency. Non-prime determines non-prime. Left hand side, X is a non-prime attribute. Then it is a problem of transitive dependency. C determines D. C is again the part of candidate key. So this is also the case of partial functional dependency. So what we have to do? We have to decompose it. So we will decompose the table. So we will bring it to 3NF. To be in 3NF, what is the important point? There should not be any partial functional dependency, because it should be in 2NF, and there should not be any transitive functional dependency. Then only we will call a relation is in 3NF. Okay. So let's decompose the relation R. So as I told you, for decomposing relation R, for decomposing first table, we keep for candidate key. What is a candidate key? AC is the candidate key. And is there any attribute which is fully dependent on AC? AC determines anything? No. So here what will happen? AC is the key. Okay, and this table is only for AC. Another table, who is creating problem? This is creating problem. A determines B. So A determines B. Now B determines anything? Yes, B determines E. So E also we will accommodate here. So now the problem of partial functional dependency is resolved, because what we did, we removed A determine B. The proper subset of candidate key, AC is the key, proper subset of candidate key A was determining B, that we removed. For this table, we will make A as key. So partial dependency problem is resolved, but the problem that non-prime determine non-prime is still there. For this table, A is acting as key. So here the transitive dependency still exists. So what we have to do? We have to divide this table further into R21 and R22. R21 will be A determines B. In this table, A will act as a key. R22, B determines E. B will act as a key. So this will be our first table. This is our second table. And this is our third table. Until here we have resolved the dependencies. Okay, so up till now the relation R is decomposed into 3 tables. This we will not consider, because here also there was a problem. For removing that problem, we divided into further tables, right? So this is first table, this is second table, this is third table. Now for this, here also partial functional dependency. So for the division, R3 will consist of C and D, because C determines D. For this table, we will make C as the key. So this relation R is divided or decomposed into how many tables? 3 tables, and 4 tables. This is the fourth one, 4 table. And now here there is no partial dependency and there is no transitive dependency, because for this table this is the key. For this table A is the key, which is determining a non-prime attribute, which is B. For this table, B is the key, which is determining a non-prime attribute, E. For this table, C is the key, which is determining a non-prime attribute, which is D. So problem is solved. Okay. So this is it for this session. In the next session, we will practice few more questions on third normal form, and we will see a short trick how to do the question properly and quickly. So thank you very much.